Hi everyone, welcome back to the Power Armour podcast. I would like to talk today about flexible forms of armour that could be used in the creation of a real-world suit of power armour or other modern military body armour. I would like to first discuss some of these different materials and designs of armour and then go into how they can be implemented in a realistic way and be used to create a real suit of power armour. So, to start with, there is obviously the classic Kevlar. Kevlar is a synthetic material that is used in bulletproof vests and other forms of body armour. It's a very strong fibre, and the way it has been explained to me is that the material dissipates energy of a projectile by breaking. Well, essentially, it takes a lot of energy to tear apart the material, and this is how Kevlar is supposedly meant to dissipate energy from a projectile, as well as providing some padding. A close historical analogue to this would of course be the good old gambeson, and you could make a Kevlar gambeson or bodysuit similar to a gambeson or akaton to wear under a real world suit of power armour, but we'll get to that a bit later. Kevlar has been around for quite a long time, and there are new materials out there which are reportedly superior to Kevlar for the same role. I have seen some experimentation of reinforcing Kevlar fibres with carbon nanotubes, and it's a bit complicated for me. I'm not a materials engineer, so it's a bit out there. I don't know if the process would be compatible with these new, stronger synthetic fibres, or if it was only compatible with Kevlar. I'm not an expert on material science. I'm a blacksmith. I have a basic understanding. Another way that people have been trying to reinforce textile armours such as Kevlar is by adding to them a shear thickening fluid or a ceramic dilatant. This is a fluid that, when struck, becomes, well, rigid or thickens on impact, in that the idea being that a material that has this added to it would become rigid on impact. And an issue with things like Kevlar is that they do not provide a rigid defense against penetration and cave in on impact. This shear thickening fluid, when added to Kevlar, has been shown to be able to become rigid on impact when it is hit with a bullet or other projectile, so that it does not cave in and spreads the force of the impact over a wider area, helping to also further reduce trauma and back face deformation of the armour. Now, I do not know if these different technologies in the more modern fibres, the carbon nanotube reinforcement and the shear thickening fluid, I don't know if these are compatible technologies, but it would be very interesting to see how well they go together and what their performance characteristics would be. However, just because a armour is flexible doesn't mean the material that is made out of has to be flexible. There has been a lot of research lately into trying to create ballistic scale armour. There's a great lecture that I've posted on the Power Armour research group. If you are interested in it, I will post a link to a very interesting lecture in the description below, discussing MIT's research into bio-inspired armor designs based on the armor of fish. This opens up the possibility of using rigid materials for a flexible armor. I would possibly also look into brigandine, depending on how you want to implement a flexible armor made out of rigid plates. And of course there is good old-fashioned articulation, as those of you who have watched my work before or seen my suit of golden armor would know that you can still get a relatively high degree of mobility out of solid plates of armor. However, my particular build is not very good, especially if you compare it to the historical examples from the 1500s that inspired it. My range of motion has several issues, but I have remedies. Alright. So why would we want flexible armors for a suit of power armor or modern body armor? So that it conforms to the body statically and allows you to make an armor that will fit more people more easily and more comfortably. The other is to conform to the body in motion, of course, enabling articulation and a range of movement while still covering the body. There are alternatives, but such as overlapping articulated plates, but for the purposes of this video we will be discussing it as something to cover areas where you need a high degree of mobility. If you're making a modern body armor or a suit of power armor that is intended to be mass produced and put on large numbers of people, then you may have issues with trying to get it to fit properly. If you make it out of plates that are able to articulate or give a little bit, you can make plates that will wrap around more bodies more easily. One of the most famous recent examples, although it is a bit dated at this point, is the Dragon Scale ballistic body armor, though that has recently been tested on Demolition Ranch, and a lot of people have been trying to make their own homemade versions to send in to be tested by Demolition Ranch, including one of our group members, Voodoo Tennessee. Hi. However, there are also companies that seem to be trying to recreate a similar commercially viable product. So you might see more modern versions of the Dragon Scale armor hitting the market in the near future. Now, if you were going to make a modern body armor with an integrated exoskeleton, such as the way most countries seem to be going with their, what I refer to as first generation power armors, such as the Talos project, the Ratnik project, and I believe Australia's one is called Carl. If you wanted to make a system like that could fit the maximum number of people, making something like a coat of plates might be an option if you want to wrap plates all the way around, and of course making as many of the plates articulate kind of like splintered armor or a brigandine. This might simplify a design and make it able to be more easily mass produced and put onto a larger number of people. So by having smaller plates attached, like on a brigandine, might be an option to try and make a suit of power armor that is more easily shaped and adjusted to fit a much larger number of people, because we've all got different body shapes, so having the armor be able to conform to us may be an advantage for the purposes of mass production. Now, the next reason being areas of high mobility, such as the shoulders and the hips and the groin region, can be quite difficult to armour in rigid plates. So, historically, what was normally done was, in the case of European plate armour, those areas were often covered by mail, even when the rest of the body was protected by plate. And I could see something like this being implemented into a real-world suit of power armour, and is the way I'm looking at doing my prototype that I'm going to be starting in the near future. Having most of the body protected by large rigid plates, but protecting some of the areas that are more difficult to armour, such as underneath the armpit, with scale armour. I'm intending to experiment on creating brigandine style or scale style. I'm going to experiment on creating brigandine or scale style voiders to go onto an undersuit, or gambeson, if you will, so that when I wear the rest of the power armour and put on the large plates, these areas will be protected by rigid material in the form of scales or brigandine in the vulnerable areas that are difficult to armour with rigid plates while remaining with a high degree of mobility. I have done armpit plate voiders before, and I'm not too keen on the level of mobility that I've personally gotten out of them. I've seen originals with much better range of motion, but but that also brings us to the other obvious reason why you would have a flexible armour, being an undersuit, such as like a gambeson, but for underneath of your suit of power armour. It can be difficult to completely encase the human body and not have any gaps. If there are any little gaps between the plates or where they overlap and articulate, there's a tiny little gap and a piece of fragmentation from either explosive if it's gone up and there's a piece of frag bounces in there, or if the armour is struck and the projectile either chips off a piece of fragmentation or in itself fragments, these small bits of material could fly in all directions, and that's something that you have to account for in your design. These fragments could theoretically get caught and go between plates. So personally, I think it would be a good idea to have some kind of textile armour for a full body suit to be worn underneath. Of course, you're going to need a cooling system for something like that, but if I was to design a real world suit of power armour, I would definitely want to have a textile armour full body gambeson worn underneath of it, implementing as many of those previously discussed technologies as possible to maximize its protection. Similar to a spacesuit, though we didn't really touch on the ballistic protection of spacesuits, but you know, that's probably for another installment of this podcast. I would want to make it full body tech suit or full body gambeson and reinforce the areas that are often reinforced in a gambeson or acton with mail, but I would be reinforcing them with either scale armour or an articulated brigandine voider, because a design like that would enable an updated version to incorporate more advanced composite materials that are not available for a textile armour. I'm not going to be building anything too extreme. I'm sticking to basic materials. I'm really focusing on actual design. And even if all goes well, there's this thing called spalling. Often it's used to describe bits of the bullet coming apart or bits of the armour coming apart on the outside when it's struck. That is how it is commonly used. However, my understanding is that the term originally meant bits of material breaking off of the back face of the armour. So you may have body armour in your superpower armour, and if it's struck by enough force, material on the inside of that armour could break away and shoot fragments of it into your body. So you would definitely want to have another layer of textile armour underneath that to help protect you. Alright everyone, if you've got any other examples of materials or ways in which flexible armours could be used in a modern body armour or suit of power armour, please let me know in the comments down below. And if you're interested, check us out on Facebook with the Power Armour Research Group. Alright everyone, see us.